Dr. Derzy, do you have a few words to say before we begin the Q&A?
I don't have many words, but it was interesting for me. And thank you everybody for attending. And are there any questions for me? Let's start with me, with myself. Please, you can use either a chat or a questions and answers window to ask questions.
I think I already see one answered question by Andreas. Roy has already answered him.
It was, yes, for RST, it was the question for OE.
Roy, would you like to expand on that, or we would move to the next question?
I just want to say that about his question is that our system works at night. So normally the wind are very low, and our sprinklers and unique water engineering doing the trick. We placed some systems next to cement factory in Guadalajara, also in Israel, in Ramle, which is a hardcore dust, and it's very hard to remove. And the system perform amazing. Our bread and butter is places that have a severe problem of dirt of all kind. So our system is modular, and it fit all the type of problems you have on the cleaning issues. Of course, if you clean the solar panels, and we had one test that didn't succeed, and when we brought the expert from Suntech, we realized that the customer before cleaned his solar panel with chemicals, so he completely ruined the anti-reflect layer. That's why the panels look like it doesn't look shiny. But if you never use chemicals on your solar panels, RST will sit perfect there and do the job. And of course, if anybody have question, you can email me to the info@rstcleantech.com, and I will supply him videos and case studies, and of course lots of pictures, and I can even point him to some of the sites near him that we already put RST there. So I think that the best way is just to approach me via email, and then I can send a lot of material and reports.
Dr. Derzy, I think this question is for you. I'm now starting to check the chat. It's a little bit difficult, but a question by Ms. Hadas Marzel. Are there countries in which aggregators also own PV roofs?
Well, as you saw in my presentation, if you own PV roof, you're in the model when you are a roof owner. But obviously you can conduct business like this. So I'm sure that there are businesses that also own roofs and also provide service to other roof owners. Just different business models. I hope, Hadas, it answers your question.
I can maybe add also that municipalities, we work mainly on EPCs and renting possibilities, and it depends a lot in the municipality's investment requests. So if a municipality has the amount of money to invest in their roofs, they will probably go with an EPC system. And if not, they will rent their roof in order to receive the amounts of money from the renting, while the solar company will enjoy the money of the solar system itself.
How successful are both models relative to each other? To the best of my knowledge, in the past it was more the issue of renting, but I think today we're moving more and more on owning the roofs by the governmental agencies and regional authorities. Yeah,
so in general speaking, the EPC system is a little bit more profitable, but again, it's like 25% more profitable, but you need to take your hand in the pocket, out of the pocket. While with renting, you don't need to invest any amount of money and directly you start getting back the investment. So it's easier for municipalities to just rent their roofs, but it's a little bit less profitable.
Okay, I think let's move to the next question. By Iris Aviezer. I wonder, are bottlenecks for multi-residential rooftops similar in the world? So I think I will start answering about that. Maybe you can join a little bit later. And most of our talk was about governmental rooftops and commercial scale. The residential scale is, of course, under the distributed solar business. That's no question about that. But the problems which we discussed here are even more severe on the residential scale. We're speaking about even more systems. I think that Kfar Saba Economic Development Corporation started projects for the citizens where they are envision 1,000 roofs in the city. We already know that in many cities in Europe, this is happening, also in the United States. There are thousands of residential roofs everywhere. And we see actually aggregators which are becoming quite big, which lease the roofs. We see this phenomenon a lot in the United States. Very big residential solar players, which basically manage everything and just rent the roofs from the owners. And on the other hand, we also see the owners which install everything, and then typically it's a kind of turnkey solution. They are being given the system by some installer with maybe 1 year or a little bit more of a warranty, and he has to manage it by himself, maybe with some monitoring app, maybe with his basic knowledge about what to do with the system, how to wash it. So responsibility is on the shoulders of the residential owner. I believe we see it quite similarly in the OECD countries. I'm not so much familiar what happens in the off-grid, mainly in Africa or Southern Asia. But in OECD countries, it's quite similar, I would say. The bottlenecks basically are quite similar. Essentially, residential systems, even whether they are aggregated and owned by some big owners, like in the United States, by big companies, or whether they are private, the amount of money where you can invest in operation, maintenance, and supervision, the amount of money, the margin is quite low. And typically, the owners don't even know how much money they lose because of dirt, or because of faulted inverter, or because of faulted panels, or anything else. So it's a kind of problem. We think that our solution with Soltell essentially can be implemented in the residential sector. We already have one of the companies which is our customer implements this for several dozen residential facilities. But again, we have to check it on a more massive scale, maybe with one of the cities. So if anyone wants to add, you're welcome. Okay, so maybe let's move to the next question. We have some questions in the Q&A. Mr. Atilak Santos, Rui, it's for you. Can you answer, please? Can you install basically RST Cleantech solution while installing the system?
Yes, we have a lot of our customers that we send them the material to sites during the solar installation, and they do it together. It's even it's considered very cost effective because the people already on the roof, and a team of 4, by the way, can install 100 kilowatt per day. So just to add one more day for the job, they can install RST as well. So no problem to merge between the two. I think in one of the aspects of the most effective.
Well, the next question I think is for me, by Yoni Ben Metzia from Girasol.
Yes.
He's talking about operation and maintenance cost in terms of equipment quality. I think this is, of course, a known phenomenon. The lower the tariffs for solar go, the more compromise is being taken on the equipment. I'm not, criticizing anyone in the industry, but we see a lot of lower quality panels. Actually, more recently, we see less. There is a kind of standard, I think, being achieved. But we do see a lot of lower quality electric components beyond that. So while the panels and the inverters do improve, the other electric components in the systems are quite low quality. This brings RESO problems with leakage and various different issues. So how does Soltell see these issues in installation? So I think this is what brings us with the predictive maintenance. So one thing is to understand that you have a problem, you have a RESO, and when you speak about distributed solar energy systems, which are 5 to 10 years old, this becomes a problem in actually most of the systems. And the question is not so much whether there is a problem. You saw, we found 91 event days per system, which is on average 5 to 10 years old. So basically there are issues in every system. And the question is just how much does it cost you? When you want to call the technician and treat the problem. So if it costs you $10 per year, you don't care. But if it costs you $1,000 per year, then you should bring a technician. And this is one of the issues we are dealing when we see RESO. So one thing again is qualitative monitoring, just identifying, okay, we have a RESO leakage problem in the system. But another way of looking at it is basically to quantify how much the leakage costs over the course of the year. And for this, you need to know how much the system has to produce optimally, and then reduce the actual production and see how much the leakage actually reduced from the system cost, from system output, excuse me. So this is what we do in Soltell. Basically, one of the issues is leakage. We quantify how much the leakage costs over the course of the year, and then it reaches a certain threshold. We just can notify the relevant owners, technical crews, and the supervisor sees that as well. And at this point, an action can be taken, a ticket can be produced. So you don't need to, manually check, just checking the air when the leakage is bad. We all know when the weather is humid, then the leakage increases. But quantifying it over the course of the year provides you the tool to basically use predictive maintenance ability to know when it is the time to treat this leakage. When do you need to bring the technician and check whether there is a leaking panel or connector anywhere in the system? And for distributed energy system, this is crucial because the cost of the technician visit is quite substantial. So you don't want to bring in just because you feel the leakage is significant. You need the actual number of how much it costs you to justify the technician to come. So I hope that answers the question. I think let's look at the next question in the chat. So question by Konstantin, I think, from how does predictive maintenance work? I think I've just answered that. So we use data from the systems. It includes generation data and of course voltage and current data, which allow us to identify which problem is actually causing the reduction of power, of output. And then when we identify which are the causes of the output reduction, we can quantify basically how much it affects the system output over the year. And then you can process this on and make it actionable. So, and this also allows us to make it actionable on the massive scale without human intervention. You don't need someone to monitor a single system and quantify how much the leakage costs there. Is it much or is it not much? We all know that, for example, typical inverters just, provide notifications that, okay, there is a reso problem, there is a leakage problem, but, all the inverters do that, which are old enough again, do that on rainy days here in this region of the Mediterranean. But this is not actionable. You cannot do much with this data. Only when it's quantified, that's useful. Rui, did you answer about the drainage in wintertime? Yeah, I think so.
What? I answered
question.
all the questions.
Yeah. No, I'm now checking the chat. So
no, that's it. I answered the question, but the thing is, when you answer the question, then it's removed the chat from open.
Yeah. I'm now checking the chat itself, and I can see that, there is another question over here. I think that's for you, by Chaim. How you clean not just dust, but also oily dust from industrial emissions?
Which, yeah, I know. I answer him.
Okay.
I answer him that because we're working at night, our system operates at night. So in most places worldwide, I'm not talking about like in the middle of the desert, but we have humidity. That the humidity soft all the hardcore dirt, and when the wash starts, we just flush it out from the panel surface. And that's how it goes. We did it, and we have next to the airports when normally it's like fuel jets on the panels. We have systems that we install on agriculture areas and cement factories. So as I told Chaim, if you want, he can send me an email and I will send him back videos, pictures, case studies. We got it all. 10 years of operation, so we got a good data.
Another question to you again by Frank Osterman. Does the RST system create any noise?
No, I also answered him. If you look at it, so far I answered all the questions, but the RST system is very, very quiet. It doesn't create noise because we have also an application for residential. So, you sit in the house, you sleep at the house, and in the middle of the night, the system starts. But it doesn't create any noise, and you won't notice that it's been washed. You're only going to see in the morning the panel's clean, and then you'll understand that it's working. Okay, all those questions, technical.
You're unmuted, Leon.
Yeah, I think we answered all the questions in the chat. We have another question by anonymous attendee. Well, I think it's just a compliment to all of us. So thank you for the compliment. PID, I think that's a question for me from Yoni. This is a good question. This is not the first time I'm being asked about PID. So PID is definitely an issue, as much as it is an issue in the utility scale and industrial scale PV. This is an issue on the roofs, and especially it's an issue on the roofs when you have hard time to access those roofs and you cannot afford the individual analysis of many roofs altogether, especially when you talk about big fleets. So identifying PID with our system is possible. We actually today don't differentiate the PID from any from any other kind of panel issue. So we do identify, by the way, panel malfunctions due to signatures in voltage and current. So for example, in mini central inverters, unlike SolarEdge or Tigo or Enphase, it's quite a challenge to identify malfunctions on panel level while doing manual monitoring. Definitely it's possible. I'm saying that as an expert on this issue who can do it manually. But you know, when you're talking about hundreds of roofs, it is simply not economical and not really feasible to inspect every roof for the voltage and for the current in each inverter, in each MPPT. It's not simply possible. So when you automate this procedure of comparing the voltages and currents, you can indeed identify anomalies in panel output, and then you can identify whether a certain array in a certain inverter has a problem. At this point, we do not differentiate whether it's a panel failure because of diode or because of any other issue, or is it PID? But theoretically, it's possible. It's just a question of algorithmics, because there is a different signature for every panel malfunction. And actually, in mini central inverters, we do that on inverter, on MPPT level. But when you have a panel level definition, like in SolarEdge, you actually have to do this analysis for each and every single panel. So it's much easier to differentiate just total failure or good activity of the panel. It's actually a little bit different challenge whether it's done on SolarEdge or Tigo or an Enphase or mini central inverters. But I think our solution for mini central inverters is quite unique because there is no alternative. The other alternative is just change everything to multiple MPPT systems. So it's possible. And again, let me go back to the original question. So PID is possible to identify. Today, we identify it all together with other panel issues. So we can notify that there is a PID, that there is a panel problem. And then if it's severe enough, if it causes enough of a loss to justify a technician, then the technician will come and identify what is the reason, whether it's a faulted panel or it's a PID issue on the entire array. I hope this answered that. Dr. Derzy, would you like to answer Attila?
Okay, I see it. Well, the deviation can be pretty big. In my calculation, in anybody's calculation, if you have 3% or 2% degradation a year, then to the end of the life, after 15, 20 years, you get to 50%. So usually forecasting, they don't take this into consideration. And as I said, you are in the la la land, hoping to get big profits. But physical degradation of panels brings you to losses. So the businesses that started 10 years ago still had 10 years ago tariffs, which were pretty high. So they can afford now not only the degradation, but to replace the panels altogether. But if you look at today's tariffs, you have to be very, very careful in projecting your profits and work very hard to reduce all the losses. So I hope this answers you, Attila.
I think maybe I can add that we made a study together with RST and the Kfar Saba Economic Development Corporation to understand a little bit the long-term effect of degradation and uptime difference between various systems. So we basically understand that from our results that we can improve with predictive maintenance and automation of monitoring. We can reduce the annual degradation by about 0.4%, because we can simply identify the issues much faster. And instead of accumulation of such issues, we can treat them on time and exactly on time, not too soon and not too late. And also Roi's solution with the automatic cleaning reduces the damage to the panels on the long term, which is another, I think, 0.1 to 0.2% degradation effect per year on the long term. So this altogether accumulates to differences of more than 10 or even 20% over the course of the lifetime. And just to understand the numbers in Igor's presentation, the average degradation of systems in the field, I mean distributed energy systems, reaches on average 2% per year. This is much higher than what is proposed in sales presentations by installers and by panel manufacturers. So first of all, panel degradation is one issue, but the whole system degradation is completely another issue. And often we see systems which are neglected to this level or another, which have a lot of faulted elements, a lot of faulted components, and reach, I saw systems at 50% uptime after just 7 years. So today we see a lot of systems just being altogether replaced, all components altogether, panels, connectors, inverters, everything. But those, again, as you said, those are high tariff systems. And in 10 years, the situation will be completely different, because at lower tariffs, it will not be worth it. That's it about this issue.
Well, I can show you shortly in Excel, Attila, if you like. And we can end at this. Share screen. Okay. Well, look at Excel, and you can see that the degradation that in the first year is small. After 20 years, it's pretty large. Also, this is your projected income, but after a long time, you can get to losses. If you play with the numbers, wait a second, I have too many windows. It's pretty difficult. This is the first time I'm doing it. Okay, so now you can play with the numbers and reduce the annual degradation to 1% of the operation costs. Well, sorry, 1% of the
Income.
Well, no, 1% of the performance.
1% of the performance, that's correct.
And still you are 20, after 20 years, you are at 20% losses. It's crazy. And you better not sleep and take care of it. And there are various reasons, physical reasons for degradation. Neglecting cleaning, cleaning with not good materials, neglecting electricity issues, weather issues, buying buying cheap equipment. Somebody asked a question about it. I think you spend less money in the beginning, then you have more degradation. And you have to think about all this stuff in advance before you start your business. And better to take a good advisor to help you with this before you start a business.
Yes, but there is, I think, the fundamental issue in the distributed solar PV is that for many systems, especially residential, but also small commercial, you often cannot afford an advisor. And that's, I think, a fundamental problem. And then you have to deal with those issues. The situation is much better in the municipal level or larger commercial level when you have owners with significant rooftops. But on residential scale, for single roof owners, it's simply a very problematic issue. And then we have to deal with the consequences. So I think we're done with today's webinar. Thank you all the participants.
Nice.
What?
More than an hour, hour and a half.
Yes. So thank you all the participants and thank you all the attendees. I hope it was I hope it was interesting for everyone. We were asked for presentation, so I think we will send presentations if you are okay with that.
Yes.
Let me know.
No problem.
Yeah. So thank you very much once again, and hopefully we will do another webinar on the issue. Goodbye. Have a nice morning or evening, depends on where you are.
Bye, guys.
Thank you.
Bye-bye.
Bye.